Thank you. Good morning. I am Seok-nam, the professor. Actually, I'm a CEO of the company here, the Neona, and also currently I'm a professor at the Department of Pathology, College of Medicine, the Catholic University of Korea. Actually, I was informed that the official language is the English for the presentation. But, you know, I saw all the speakers give a presentation, our language Korean. But I already prepared the presentation by using English, so if you don't mind, I give my presentation by English, okay? I think this presentation is the very little bit a first step toward for our future collaboration or investor relationship between you and our company, Neona. Okay, I don't think many people knows about my company, Neona, because this company has been established in last August, year 2020. So it's a pretty new venture company. It's been less than 1 year. Actually, like most of venture company located in the university campus, our Neona is also is the research-based and the anti-cancer drug development company based on my more than 20 years of the research career in RNA cancer genomics field. Okay, this slide shows why we named the company name as Neona. As you know, neo means the new things, and we pursue the new concept of the RNA therapeutics in especially cancer. So we put these two words into the single name as the Neona. So our company Neona develops the RNA and oligonucleotide therapeutics that target RNA and its regulatory factors in the processing of the RNA networks. Actually, the RNA life cycle is very, very complicated, as you can see here. The RNAs are regulated through the dynamic and diverse process within the cells, and also these complicated RNA regulatory networks are regulated by various factors, which we call them RNA regulatory factors. So our company, Neona, aims to become a leading company in the development of RNA therapeutics that selectively target RNA or RNA network regulatory mechanism for disease, especially for cancer, based on our original technology for clinical naval verification research data. Our company located in the Seoul St. Mary Hospital campus, as you can see here, just next to the hospital. Here is the medical school building. We are here. And also you can see some forest area which is heavily under the construction for new building complex. It will be finished at the end of this year, and we are planning to move this area in next year with some space area. When we start our company, we prepared 4 different 5' lines. Of these 5' lines, 3 5' lines are basically the RNA targeted and RNA-based anti-cancer therapy. And the last one is the multi-panel-based, the early diagnostic the tools, especially for the liver cancer. Of these, the 3 RNA-targeted RNA therapy, the 5' lines, the first one is especially focused on the small microRNA, LES7I5P. This LES7I5P has a very pivotal role in the regulation of macrophagy. And then the second one is we recently found some RNA splicing factors are deregulated in the development of the liver cancer. And also we found some enhancer molecules are also deregulated in the development of liver cancer. So we targeted these molecules by using siRNA techniques. Today, due to the time limitation, I'm going to show some data about the first 5' which modulate macrophage immunoactivity to cure the cancer. In normal physiology, macrophages recognize the damaged cells to clear them, and at the same time, to avoid hyperactivity of the macrophages, most of normal cells interact the macrophage cells by interacting with the specific ligand sulfur alpha molecule with their specific receptor CD47. However, recently many scientists discovered many different kind of cancer cells mimics like these normal cells. They do express CD47 molecule and also interact sulfur alpha ligand to pretend as a normal cells, and then by using this they can avoid the macrophage attack. So many of big pharmaceutical companies now, they are developing CD47 antibody, which interfere the association between macrophages with the CD47 tumor cells. However, unlike this mechanism, our company discovered a very unique mechanism which modulate the immunity of the macrophage cells. In liver cancer, histone deacylase 6 is a very potent tumor suppressor gene. And this HDAC6 should suppress LES7I5P in normal status. However, once inactivated or suppressed, these LES7 5P microRNAs are re-expressed so that it can suppress the thrombospondin molecule. This is very important molecules that act as a endogenous anti-angiogenic molecule inside of cells, so that it cannot interact with CD47 receptor. So this CD7 receptor is open to bind to the sulfur alpha ligand of the macrophages. So this switch the status of the macrophage as the emit signal to don't emit signal, so that macrophages no longer attack tumor cells. Here is some data. We harvest mouse peritoneal macrophage and co-incubate with human tumor cell SNU-23 cells. And at the same time, we treated it HDAC6 plasmid or antisense oligonucleotide of the LES7I5P or the thrombospondin proteins. And as you can see here, all these 4 treatments enhanced macrophage phagocytosis activity. As you can see here, the fluorescence color means macrophage already eat the tumor cells. And when we pre-treated 3F352 antibody, which is the anti-CD47 antibody that specifically blocks the binding of thrombospondin to CD47, they are, as you can see here, dramatically inhibit all these 4 different treatments. So with this result, we were able to make a conclusion that, as I mentioned earlier, in normal status, HDAC6 should suppress LES7I5P. However, once inactivated or suppressed, it re-express it to inhibit thrombospondin proteins. Then this causes to open the CD47 receptor, so that binding of the sulfur alpha ligand to the cancer cells. And then, as I mentioned earlier, this critically switched macrophage to the don't emit signal status. Okay, here is some in vivo data. So we prepared the animal model, which developed the endogenous liver cancer around at 20 weeks of age. As you can see, the heavy liver mass and numerous liver cancer mass in the animal model. However, when we treated it, HDAC6 plasmid or antisense, LES7I5P or thrombospondin, all these treatment significantly suppress the instance of liver mass or size of liver mass in the same animal. And the immunohistochemistry, we were able to confirm these results by the observing the, as you can see here, this the staining with specific macrophage marker F480 staining shows that some the lot of numbers of macrophages compared to non-treatment. So our pipeline, the RT-LES7 therapeutics specifically focus on the LES7 I52 micro RNA so that it re-express the thrombospondin protein, then it can occupy the CD47 receptor, and then these interfere the association between cancer cells and macrophagy for the don't-emit signaling and to the switch it to the emit signaling. Okay, currently, as I mentioned earlier slide, many of big pharmaceutical companies, they're developing anti-CD47 monoclonal antibody, especially for the non-Hodgkin's lymphoma or ovarian cancer or other type of cancer here. Because all these cancers express relatively high level of CD47 molecules. Then what happened to the other cancer? For example, like liver cancer, as you can see here, they show the relatively low level of CD47 expression. And more, when you look at the CD47 differential expression in various cancer, you can only find the 3 cancers shows differential expression of CD47 molecules in cancer compared to corresponding normal. However, okay, skip this one. However, when you look at the differential expression level of thrombospondin molecule in various cancer, we can find more than 60% cancers. They shows the very suppressed expression of this thrombospondin molecule. So our approach is to regulate the microRNA LES7IP strategy can be applied to broad range of the cancer. All these data has already published in the hepatology, and we hope we can enter the phase 1 clinical trial in year 2025. So we are currently spending very hard time to develop these therapeutics. Okay, I think I must stop here, and I appreciate for your attention. Okay, thank you.